So this is lesson 4.3, another form of the equation of a linear relation. So what we're going to do is we learned on the last lesson slope-intercept form, y equals mx plus b. Well, sometimes they're not given to you in that form. It's given to you in what's called general form. And you can see the process here, ax plus by plus c equals 0. And what we want to do is we need to be able to go back and forth between the two forms. So for instance, the first example here is 3x minus y minus 5 equals 0. We need to rearrange this. So we got to get y by itself. So we got to move this 3x, this positive 3x. So we know algebra-wise, to get rid of this positive 3x, we subtract 3x from both sides. So we do that. So then we get negative y minus 5 equals negative 3x. Careful of your signs when you're moving these around. Then we have to get the negative 5 over to the other side. So the opposite, negative 5, positive 5. We add 5 on this side and add 5 on this side. Now, this may look correct down here, this negative y equals negative 3x plus 5, but it's not. Y has to be positive. So to do that, what we can do is we can multiply or divide all of these pieces here by negative 1. Basically, what you're doing is changing the signs. So you you multiply everything by negative 1 here, and you end up with y equals 3x minus 5. So then it's in slope-intercept form. We can see that the y-intercept is negative 5, and the slope is 3. And remember, that's 3 over 1. Okay, next page. So let's look at an example here. So first thing is we have a word problem. Two integers have a sum of 3. Write the equation to help us find the solution. So look at this, two integers. So the two integers are x and y. We add them together, right? That's what an equals 3. So the sum of 3. Well, we don't like this form. Let's rearrange it. Let's put it in slope-intercept form. So to do that, we're going to move the positive x. So to move the positive x, we subtract x from both sides. Right? So then we end up with y equals negative x plus 3. Now it's in slope-intercept form. So you can either graph it based on that, or if you remember, we can use table of values. So table of values here, we put our x's and y's down. And how do we pick our x's? You just pick some random numbers. Pick normal numbers, not anything like 20 or negative 1,000 or anything like that. So pick 0, 1, negative 1. Those ones work. So then all we do is we plug them into the equation, right? So let's plug in 0. So y equals negative times the 0. That's still 0. Plus 3, so our answer is 3. And then we do 1. So y equals negative 1 plus 3, which is 2. And then we do negative 1. Y equals negative 1 times a negative is a positive, so we end up with that. Positive 1 plus 3 is 4. Then put them on the graph. Remember, we start at the origin, and then do your x's first, then your y's. So the first one, 0, 3. 0 doesn't mean we go left or right. The y being positive 3 means we go up 1. There's our point right there. 1, comma 2. So we go back to the origin again. Positive 1 on the x over here. We go to the right and then up 2. And we do the third point. Now, you know you've done it correctly because those points should line up. And we picked 3 points because one of them is like a checkpoint. So if you don't get those 3 points lining up, go back and check your math. You've made a mistake someplace. Okay, so let's look at this next example. What if x wasn't there? So we go back up to the original equation from the previous page, x plus y equals 3, and just get rid of x. So all we have is y equals 3. Well, it's just like it looks. What is y every time we pick a value of x? Every time we pick a value of x, y equals 3. So table of values, throw some values of x down. So we picked 0, 1, negative 1. But when x is 0, what's y? Well, it's 3 right there. If x is 1, what's y? It's 3. If x is negative 1, what's y? It's 3. So this is kind of a weird looking line. So when we graph this out, if you notice, wow, it's a horizontal line, right? Parallel to the x-axis at y equals 3. So horizontal lines have the equation y equals whatever the number is. So for instance, if it was y equals negative 5, you'd have a horizontal 5 way down at negative 5. If y was positive 10, we'd have a line way up the top at positive 10. But it's a horizontal line. That's the key there. So when it's y equals, it's a horizontal line. All right, next page. Let's go back to the original equation and ask the same thing. What if y wasn't there? So we get rid of y. So we have x equals 3. So in this case, every time we pick a value of y, we're going to have x equal to 3. It doesn't change. So in this case, when we do our table of values, you don't pick x values because those are already given to you. You can pick y values, random y values. So 0, 1, negative 1. So when y is 0, x is 3. Kind of get the pattern here. Now, if you plot these out, you don't get a horizontal line, you get a vertical line parallel to the y-axis. So that's our explanation down here is vertical lines have the equation x equals whatever it happens to be. So if x was negative 5, you'd have a vertical line over here in this quadrant at negative 5. Okay? Okay, next one. positive and negative slopes. So when we're talking about slope, remember the m is the value that represents that, you can have either a positive slope or a negative slope. And how we determine that is if you look and you start always on the left. In this case, you can see that we're going up. We're going up here and to the right to get points. If it goes up and to the right, it's a positive slope. Look at this one over here. We start on the left again, but this time we're going down and to the right. Now, if you notice, it's right every single time. It's either up or down, though, that dictates whether it's positive or negative. So in this case, if it's going down and to the right, we have a negative slope. So up and to the right, positive, down and to the right, negative. Okay, on to this last page now. So here's a typical example. You're going to get an equation like this. So you got 3x minus 2y equals 6, and we want to sketch it. Now, in this case, I'm giving you the values of x. I'm not giving you random values. So one of the things we can do is we can rearrange this so it's in slope-intercept form. So we could do that. Or if you don't want to do that, could you actually just use this equation and plug it in? Sure, why not? Let's do it that way. So we've got 3x minus 2y equals 6. So let's plug in the first value of x, which is 4. So 3 times 4, right, in here, minus 2y equals 6. So 12 minus 2y equals 6. Well, how do you get rid of the 12? Subtract 12 from both sides. So we end up, right, these cancel out, and we end up with negative 2y equals, okay, 6 minus 12 is negative 6. So we end up with negative 2y equals negative 6. Y is still not by itself. We have a negative 2 attached to it, and the negative 2 is attached by multiplication. So how do we get rid of that? We divide. Divide both sides by negative 2. So negative 2 and negative 2. Now remember, those don't cancel because cancel means 0. Those reduce down to 1. Let's use the proper terminology, right? So y equals negative 6 divided by negative 2 is 3. So our first value of x, and then we end up with a 3 as our y value. Now we can do the same thing for both the other ones. So 0 and negative 4. And you can see we did the work down here. So we plug in 0. Nice thing about timesing by 0 is it just disappears. So we end up with negative 2y equals 6. Divide both sides by negative 2. We end up with y equals negative 3. Over here, we're plugging in negative 4. So 3 times negative 4 is our negative 12. We add 12 to both of these this time. So we end up with negative 2y equals 18. Divide both sides by negative 2. We end up with y equals negative 9. So there's our 3 points. And remember, we know if we did it correctly because when we plot those 3 points, it should form a perfectly straight line. And you can see bang, bang, bang. We put the points on there, draw our line with our arrows on the end. You've done it correctly. Now, if you wanted to, you could have gone back up here originally and rearranged this into slope form and then done all the math. You might have found that easier only having to rearrange it once instead of 3 times. But that's your decision. All right, that was lesson 4.3.